Hi students, welcome back to ChemOrgChem. So in this NEET Chemistry 360 series, we have been exploring the solution for previous year NEET Chemistry question papers. If you are new here, don't forget to subscribe and hit the bell icon for notification. Let's see what's today's problem. This is the question from NEET 2025. As per this question, here they given three compound structure. Here we are asked to find out the correct order of bond dissociation energy of the CH bond, so which are marked with asterisk mark. So here you can see that there are four options are given. Let's solve together to find the correct option for this question. In order to solve this type of question, first we should know about what are the factors that affect or control the CH bond dissociation energy. There are two factors. So first one is hybridization of the carbon atom and second one is stability of the resulting radical. So first talk about hybridization of the carbon atom. So the based on S character. So more S character, which means that electrons held closer to the nucleus. So resulting that we need more energy to break that CH bond. So therefore we can consider that stronger CH bond. So resulting that higher bond dissociation energy. For example, so if hybridization is sp, therefore 50% of S character, so which means that we need to give more energy to break that CH bond. In case of sp3 hybridization, only 25% of S character is present. Therefore, if you give least energy, we can break that CH bond. So let's moving on stability of the resulting radical. So if more stable radical is formed, so therefore we can easily break that bond. So resulting that lower bond dissociation energy. However, when you talk about radical stability, so therefore we need to consider several factors including resonance, aromaticity disruption, ring effect. So therefore here we could consider only hybridization of the carbon atom. So let's moving on. So here if we find the hybridization of this particular CH bond, we can easily solve this question. I hope most of them know how to find the hybridization of given CH bond. If you don't know, no problem. Let's see briefly how to find the hybridization. So for that, first we need to count the number of atoms and including lone pair of electrons. So if count is 4, so your atom is sp3 hybridization. If count is 3, your atom is sp2 hybridization. If count is 2, your atom is sp hybridization. So for that, let's take some example. So now you can see that if we want to find the hybridization of this carbon atom, you just follow this rule, count the number of atoms around with this carbon. So only 4 hydrogen atoms are present. Here no lone pairs are available. Therefore our count is 4. The hybridization of this carbon atom is sp3 hybridization. Moving to the one more example. So now if we want to find the hybridization of this carbon atom, just to follow the same rule and count the number of atoms around with this carbon. 1, 2, 3, only 3 carbon atoms are present and no lone pairs are available. So therefore the count is 3. The hybridization of this carbon atom is sp2 hybridization. Let's moving on one more example. So now if we want to find the hybridization of this carbon atom, so just to count the number of atoms around with this carbon atom. So only 2 carbon atoms are present, no lone pairs are available. Therefore the count is 2. Therefore this carbon hybridization is sp hybridization. Okay, let's see the hybridization of our given molecular framework. So this is our first structure. So here we should find out the hybridization of this carbon atom since they are asking this CH bond dissociation energy. So now you count the how many atoms around with this carbon. So here 1, 2, 3, only 3 atoms are around with this carbon atom and no lone pairs are available. So therefore the count is 3. So therefore the hybridization of this carbon is sp2 hybridization. So let's moving on our compound number 2. So here they are asking this CH bond. So therefore we should find the hybridization of this carbon atom. So now you count the how many atoms are present around with this carbon atom. Only 2 atoms, here one and another one is here. So therefore the count is 2. So the hybridization of this carbon atom is sp hybridization. And let's moving on our final structure. So here you can see that now we should count the how many atoms around with this carbon atom. So 1, 2, 3, 4. So the count is 4. So therefore the hybridization of this carbon is sp3 hybridization. Now we successfully found the hybridization of particular CH bond in all the molecules. So based on that, we can easily arrange the order of bond dissociation energy. So based on this series, so sp has highest s character, which means that higher bond dissociation energy. So here is sp hybridization, therefore which comes first, and next would be a compound 1 and final one would be a compound 3. So based on that we can arrange the order of bond dissociation energy. So which is second molecule has more bond dissociation energy and third one is lowest bond dissociation energy among the 3 molecules. So let's moving to the our question. So as per our discussion, among the 4 answer, the correct option for this question is option 2. That's it for today's problem. I hope this video has helped you to understand this question. If you enjoyed this session, just give it a thumbs up and share it with your friends. And don't forget to subscribe ChemOrgChem for much more content like this. And finally, thanks for watching. Bye bye.